Okay, good afternoon. And good afternoon. So this is our last topic for chapter 2. Okay, so we have discussed this already a bit. Okay, a preview last lecture natin. Okay. So this is our last topic, logic gates. Okay. So we have how many? 6 basic logic gates. So we start with AND gate. Okay. AND gate is 7408 IC. So we have 7400 series. Okay, so we're going to discuss 7400 series. Okay, starting with AND gate. So AND gate is a multiplication operation. So let's say we have AB or XY. So it actually means A times B, right? Just like in your algebra. Okay, so when you say A times B, it's actually in logic circuits or in digital electronics, it actually means A and B. Okay, so what does this and means? And is an AND gate. Okay, so an AND gate, so this is a truth table for AND gate. So an AND gate is actually a 7408 IC. Okay, so let's peruse first the truth table for AND gate. Okay, so we have two inputs. So these are the inputs, this side. Okay, 1, 2. Okay, and this is the output. Okay, so let's say you have input A, B, and the output is C. So your C is actually equal to AB. Okay, so we have two inputs, 2 to the n, 2 raised to n. So 2 raised to 2 is actually 4. So we have 4 combinations, four possible combinations. So 0, 0, which are 0, 0, 0, 1, 1, 0, and 1, 1. So for A times B, so any number multiplied by 0 is 0. So for 0 times 0 is 0, 0 times 1 is 0, and 1 times 0 is also 0, but 1 times 1 is 1. Okay, so this is the IC configuration for 7408. Okay, the 7400 series is actually 14 pins. Okay, 14 pins. Okay, so if you're going to have the actual IC, so you will have like a U shape here. Okay, then you have a dot here. So you will have a dot somewhere here. And that dot signifies the 1. Okay, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so you have 14 pins. So this IC is called deep dual inline packaging. Okay, so why dual inline? So you have the pins on both sides. So you have here and this side. Okay. And then this is also a quad IC. Quad, when you say quad, that means 4. So this IC consists of 4 gates. Okay, so we have 1, 2, 3, 4. Okay. So each gate has 2 inputs. So for, let's say, for AND gate number 1, so you have inputs for 1 and 2, and then output at taken 3. Okay, for AND gate number 2, so we have inputs at 4 and 5, output it taken at 6. For AND gate number 3, so you have inputs are at 9 and 10, then output is taken across at 8, pin 8, and lastly, so you have pin 12 and 13 as your inputs, so we have pin 11 as the output. And of course, you have to supply the IC for it to function. So you have to supply pin 14 to positive supply and pin 7 to ground. Okay? Question for AND gate. Question?
Wala po.
Okay, clear? Okay. Then next we have the for NAND gate. Okay, NAND gate is a 7400 IC. So a NAND gate is actually an inverter followed by an AND gate followed by an inverter. So you have the bubble here. Okay, so an inverter can be represented either by by a triangle, then a bubble, or just a bubble alone. Okay. So we have, okay. So since the output is the reverse of the AND gate, so whenever you have an input of 0, the output is 1. So such that 0 times 0 is 1, 0 times 1 is 1, 1 times 0 is 1, and 1 times 1 is 0. Okay? So the output of NAND gate is actually just the opposite of AND gate. Okay? So this is the IC diagram of NAND gate. Okay, so as you can see, it it has the same pin configuration with AND gates. Okay, so this is also a quad IC. So we have a 4 NAND gates. Okay, so we have 1 and 2 as inputs, 3 as output, 4 and 5 as inputs, 6 as an output, 9 and 10 inputs, then 8 output, and then 12 and 13 inputs, and 11 as output. So again, 14 and 7. So you supply the positive and negative supply, positive and ground respectively. Okay, that is for 7400. And then we have OR gate. So OR gate is signified by plus. Okay. So when you say A plus B, it actually means A or B. Okay, A or B. So plus is again is okay. If you have to implement plus, you have to use OR gate. Okay, OR gate is 7432. So plus, so if you have an ORing or plus, so whenever you have an input of 1, the output is 1. Okay, such that if you have 0, 0, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 1. Okay, so for digital electronics, okay, we only have two values, 0 and 1. So 0 means, then we have NOR gate. Okay, so for NOR gate, we have this is 7402, so no OR gate with inverter. So as you can see to the diagram, so it's actually OR gate plus bubble. Okay. So again, when say bubble, so it means inversion. Okay. So since this is a NOR gate, any input of 1 would have an output of 0. Okay, so any input of 1 would have an output of 0. Okay, so in Boolean equation, so for this is the Boolean equation for NOR gate. So you add it first, then open and close parenthesis, then prime or inversion. Okay, such that 0 plus 0 is 0, then invert 1. 0 plus 1 is 1, invert 0. 1 plus 0 is 1, invert 0. So 1 plus 1 is 1, invert 0. Okay, so that's how we got this, the output here. Okay, so take note. So the IC diagram of 7402, this is for NOR gate, is a bit different from the three ICs that we have discussed. Okay, so it's different from 7400, 7432, and 7408. So take note that the output now is taken for NOR gate number 1. The output now is taken across at pin 1, whereas the inputs for NOR 1 is 2 and 3. Okay, for NOR gate number 2, the output is to be taken at pin 4 with inputs at 5 and 6. Okay, for NOR gate number 3, so you have 8 and 9 as inputs, pin 10 the output, and 11 and 12 inputs, then pin 13 as output. Okay, so again 14 and 7, so you have to supply them with BCC and ground respectively. Okay, question. Okay, so we have now XOR or exclusive OR is a 7486 IC. So as you can see, this now the symbol for XOR. Okay, it's like an OR gate with a line here, curved line at the input. So you have a, what do you call that? Convex or concave. Okay, so it's like a concave line here, okay, at the input. Okay, so XOR, so you'll have an output of 1 if the inputs are different. So like this one. So if you have 0, 1 or 1, 0. Okay, so if you have different inputs, so that's when you'll have an output of 1. Whereas if you have the same inputs, let's say both A and B are 0 or both A and B are 1, so the output is 0. Okay? So therefore, whenever you see a Boolean algebra that is equal to, for this one, A prime B plus AB prime, so that means that you can represent that by a single IC XOR. Okay, so this is the pin diagram for 7486. So you have fairly the same diagram for 7400, 7402, and 7432. No, not 02. 7400, 7408, and 7432. Okay. So we have 1 and 2 as inputs for XOR 1. Pin 3 output, 4 and 5 inputs, XOR 2, then 6 as an output, 9 and 10 inputs, so we have pin 8 as output, and 12 and 13 inputs, and 11 as an output. So again, 14 and 7 are for your supply pins, okay? Positive supply for 14 and ground for pin 7. And lastly, we have XNOR. Okay. No, it's not the last. Okay, we still have the inverter and buffer. So we have exclusive NOR is 74266. So it's XOR plus inverter. Okay. So for XNOR, so whenever the inputs are the same, so that's when you'll have an output of 1. Okay. So if you have both inputs are 0, so you'll have an output of 0. Both inputs are 1, so you'll have an output of 1. Okay, so that is XNOR. So in terms of Boolean algebra, whenever you have a statement, A prime B prime plus AB, so you may use a gate XNOR. Okay, but then if you can't able to buy XNOR, so you may use XOR plus inverter. Sorry for my cracking voice. I still have cough class, sorry. Okay, pardon. Okay, but then let's check for 74266, okay? So here we have, okay. So it seems that, it seems that only NOR gate has different IC diagrams. So 74266, so we have 1 and 2. Okay, 1 and 2 as inputs, 3 outputs, 5 and 6. Okay, so it has different so this one's different also. 5 and 6 as inputs, so you have 4 output, 8 and 9 as inputs, 10 output, 12 and 13 inputs, and 11 output. So we have VCC positive and 7 to the ground. Question class, question so far? Class, am I too fast? Hello?
None po, ma'am.
Okay. Uy, we're already 18. Okay. Then we have inverter. Inverter is a 7404 IC. Okay, so this is the symbol for inverter. Okay, so triangle plus a bubble. Okay, so inversion means if you have a input of 0, the output is 1. If you have an input of 1, the output is 0. So let's say the input is A, the output is B, such that B is equal to A prime. Okay, so this is now the 7404 hex inverter. Hex, so meaning we have 6 gates. Okay, so for first inverter, for inverter gate number 1, so you have 1 as input, 2 as an output. For inverter gate number 2, we have 3 inputs, 4 output. Inverter gate number 3, so you have 5 as input, 6 output. For gate number 4, we have 8, here, sorry, 9 as input, 8 output. Inverter 5, so you have 11 as input, 10 output, and 6, so you have 13, pin 13 as input, and pin 12 as output. So again, 14 and 7, so you supply it with positive supply and ground. Okay? And okay, so we have no buffer, so we have 7, okay? 7 gates. And those are, so can we have a recap? Anyone? You still remember? So we have hex inverter 7404, 74266 for XNOR, okay, 7486 for XOR, 7402 for NOR gate, okay, 7432 for OR gate, 7400 for NAND gate, and 7408 for AND gate. Okay, so we have discussed 7 basic logic gates so far. Okay. Question, class? Question? No? Question?
Wala po, ma'am.
Okay. Mm-hmm. Okay. So, the next topic is, so how we're going to implement or make a circuit given the Boolean equation. So, you already know how to simplify a Boolean equation. So, the next step would be, so how we're going to make a circuit given the Boolean equation. So, example here. So the equation is x is equal to AB prime plus BC. So we already have this last lecture, but okay, so this serves as a review. So again, we start with AB prime term. Okay, so we have 2 terms, okay? So we have term number 1 is AB prime, and then the second term is BC, okay? But then we have, how many literals do we have? So 1, 2, 3, 4. So we have 4 literals, okay? So why do we need to simplify the equation? To lessen the number of, to simplify the circuit, okay? The less number of literals, less wirings you would need. So for AB prime, so let's start with AB prime. Okay, so let's start with AB prime. So of course you have to invert the B first. So to invert B, input B, so you would need to have an inverter. So we have an inverter here, which is connected to the B. So again, so only heavy dot means connection. No heavy dot means not connected. So like this one, so you have intersection here, but there's no heavy dot. So that means there's no connection, okay? Okay, so we have, okay, so B prime. So to have an output of B prime, so you have to use inverter and then connect it to the input B, okay? So the output of inverter is B prime, okay? So what IC is this? So you would use 7404. Okay, so we'll need 7404 for this. Okay, and then take note that the 7404 is a hex inverter, so you already have 6 gates there. Okay, and then B prime, multiply it times A. So to be multiplied to A, so that means you have to use an AND gate. Okay, so we have an AND gate here. Okay, so the output of an inverter is to be inputted to the input of an AND gate. Okay, and then the other input would be connected to A. Okay, so this is now B prime. This input is B prime, and this one is A. And then this is an AND gate. So what it does is A times B prime. So therefore, the output of this AND gate is A times B prime or AB prime. Okay. So again, what IC is this? AND gate 74. What gate is AND gate? 74. What number of IC? 74. Is this 7408? Class? What is AND gate? Class? What number is AND gate? 74? Hello? Are you there? What is AND gate? 74?
86.
7486 AND gate.
Hindi, ma'am.
It's 7408.
08. Joke lang, ma'am.
Okay. So it's 7408. Okay, so it's 7408. Okay. So if we're going to buy IC in, let's say in, what do you call that store? I forgot already. Deco. Okay, so whenever you're going to buy IC in Deco, so you'll say 7408, 7404, 7400 IC. Okay. So we have AB prime. Okay, now you have a, okay, so you already have AB prime here. Then let's proceed to BC. So BC is just simply AND gate. So it's actually equal to B times C. Okay, BC is B times C. So you have to use AND gate here. So it's a 2-input AND gate. So one input is connected to B and the other input is connected to C. So we have now AB prime and BC. Okay. And then, okay, so you now have AB prime, BC done. So to connect them, so you need an OR. You need a plus. Okay. AB prime plus BC. And what is plus? Plus is an OR gate. Okay. OR gate is 7432. Okay. So what they're going to do? So the output of the AB prime, so this is AB prime. Okay, you connect it to the one input and BC. Connect BC input to OR gate input. Okay, so that, okay, after that, okay, so this will be your X. So your X is now equal to AB prime plus BC. Okay, question? Question?
None po, ma'am.
Okay, so to implement this circuit, so how many IC you need? How many IC?
4 po.
Why 4? How many gates? So gates 1,
4 gates
2,
po.
3, 4. So you need 4 gates. But how many IC? IC means integrated circuit. Okay? So that's the black packaging you see in a printed circuit board. So it's actually IC. So how many IC you need? So for, let's say you're going to buy 7408 for AND gates. So again, for AND gates, how many gates in a single IC? How many gates in a single IC? Let's take a look again. Okay, let's review. Let's have a review. Okay, going back from 7408 AND gate. Okay, so you're going to go to decode, then you'll say to the sales lady, may I buy 7408 IC? Okay, and this is the IC diagram of 7408. So how many gates? 1, 2, 3, 4. Okay, so in the circuit, okay, so we have discussed. So how many AND gates do we need? You only need, hello? How
Two
many
po.
IC? Okay, you need 2 gates, okay? So you might need this one. You might use this, okay? AND gate number 1 and AND gate number 2. Okay, so you still have 2 gates spare. So how many IC you need to how many ICs you need to buy if you're going to use 2 gates? How many ICs do you need to buy if you're going to use or need 2 gates? Only 2 gates. How many ICs? How many 7408?
So lang, ma'am.
Okay, so you only need 1. Okay, so what else? Okay, so we also need an OR gate, right? Okay, 7408, 7432. So aside from 7408, so you need to buy 7432. So again, this is the IC diagram 7432. So you're going to buy it to Dico. You're going to say, sales lady, may I add 7408? And this is the IC diagram 7408. Okay, 7432 rather. Okay, so this is an OR gate. So again, 7432 has 4 OR gates. So 1, 2, 3, 4. So how many OR gates do we need for the given circuit that we have discussed? How many OR gate?
Dalawa.
Huh?
4.
How many OR gate?
4.
The 7432 has 4 OR gates, okay? But how many OR gate do we need? How many OR gate? How many OR gate do we need for this?
1.
Okay, so only need 1. Okay? But then every time you buy an IC, you'll have 4 gates. So that means you have 3 gates spare. Okay, and lastly for an inverter, so we have hex inverter 7404. So how many inverters?
6.
Okay, so you have 6 inverters for 7404 packaging. Okay, but you will only need 1. Okay, so that means you have 5 spares. Okay, so that means how many ICs do we need to implement this Boolean algebra? So we need 1 IC for this, for B prime. We need 1 IC for AB prime and BC, and another IC for AB to connect the 2 terms, okay, to have an output of X, to connect AB prime plus BC. So you need 3 ICs for this equation, okay? Do you understand, class? Or you need more example?
More, ma'am, more.
Okay, so we need more example, okay? So we have here, okay. Okay, so let's have number 2. Okay. Okay, so ABC plus A plus B plus C. So to have ABC, so what gates do we need? So of course you have to C prime. So how are we going to have C prime? Class, how are we going to have C prime? Class?
Inverter po.
Okay, so we need an inverter. Okay. Okay. So we need C prime. Okay. Okay. Insert. Okay. Okay. So, okay. So we now have C prime. Okay. And then you have AB. Okay. So let's have AB first. Okay. So we associate AB first because we only have, take note, the AB, A times B times C prime calls for three input AND gate. But we only have two inputs, right? Class? Okay. So it actually calls
Yes
for
po,
three
ma'am.
inputs, but we only have two inputs. Okay. So if we're going to buy 7408, so it only has two inputs. So we need to have a, for AB. Okay. So let's say this is our AB. For AB, we have, okay. Okay, assuming it is straight. Okay, okay. What else? Okay, so to indicate connection. So this is AB, and then what's next? AB times C prime. Okay. Let's move it backward. Okay, C prime times AB. Okay, C prime. Okay, so C prime times AB, so the output of this. Okay, the output of this. Okay. Okay. So therefore, this is now AB times C prime. Okay, so the gates here, so this gate now is equal to, the output of this gate is AB times C prime. Okay, so first we have C prime, and then we associate A and B, A times B. So we have an AND gate here. Okay, inputs A and B. The output is A times B. And then another AND gate. Okay, so this is AB and this is C prime. So the output is AB times C prime. Okay, so we now have our first term. So for second term, we have, okay, so for second term, A plus B plus C prime. Okay, so let's associate A plus C. Okay. Okay, A plus C, and then C prime. Okay. Okay, so A plus C. So what gate is this? To implement A plus C, so what gate do we need? Class, what
Or
gate do we
po.
need?
Or
Again?
gates. Or
Okay, so we
gate.
need an OR gate. Okay, so we need an OR gate. Okay, so we need an OR gate. Okay. Okay, so inputs are, so we have A and C. Okay, A and C. Okay. Pardon my drawing. I know you can do better than this. Okay. It's not even straight. Okay. So then heavy node. Let's put heavy node. Heavy node means connection again. Okay. Okay, so this is now AN, A plus C. So we have A plus C. This is A plus C. Okay, next we have, okay, so we need to have another B prime. B prime, okay, so we have, just copy, where are you? Okay. Okay. Okay, B prime. Okay, B prime. We have to extend B. Okay, B. Any question? Question? You may ask question anytime, class, while I'm drawing this. Okay, so this is B prime. Okay. B prime. Okay. Okay. So we need to be uniform. Okay, B prime. And then what's next? A plus C plus B prime. Okay. We have A plus C. We already have A plus C. We already have B prime. What's next, class? What's next?
Plus.
OR gate.
Okay, so we need another OR gate. Okay. We need another OR gate. Okay. Another OR gate. Okay. Then, what else? You may ask question. Okay, so this is now. Okay. So that's why associative property. So we're actually using the associative property. Okay, so if there's a need for 3 inputs, but then the gate is only 2 inputs, okay, 2 input gates. So you need to associate the A plus C first, then you add it later on to B prime, okay? So this term, okay, this term actually calls for 3 inputs, right? So you have 3 inputs, A plus B prime plus C, but you only have 2. But you only have 2 inputs. So that's why you need to do a cascading, series of cascading. So 2 at a time, the A plus C first, and then later with B prime, okay? So now we have A plus C plus B prime. So we already have this term, and what else? ABC prime, okay? So we have ABC prime. So to connect these terms together, 2 terms, so we have term 1 and term 2. So what do we need? What connects them? Okay, so you need a plus. So we need an OR gate. Okay, so we already have an OR gate here. Okay, so we only need to connect them. So connect the ABC prime and what else? So we need to connect the A plus C plus B prime. Okay, and this is now your, okay, so we have ABC prime plus plus B prime plus C. Okay? Easy, right? Question? Question, class? Okay, for your seat work, okay, I'm going to wait for your seat work. Okay, submit it in 30 minutes time. Please, please try to do this number 3. Okay.
Ma'am,
Yes.
pwede sa papel ma'am mag-drawing?
Yes,
Parang hirap
yes,
po sa word.
yes. Yes.
Okay, ma'am.
So this is yes, please do number 3 and then submit it 3:30. Okay? 3:30. Okay? I'll be waiting for your
Number 3 po,
answers.
ma'am.
Number 3. Seat work. Are you doing it right now, class?
Yes, ma'am.
Okay.
Ma'am,
Yes.
paano po ulit yung diagram ng AND gate? AND gate. Okay na po, ma'am. Thank you po. Kita ko na po.
Ma'am, paano ko po isi-send?
Please take a picture and then MS Teams.
Okay po, ma'am.
Hello? Are you done?
Yes, ma'am.
How
Yes
about
po,
the
ma'am.
others?
Iba mo dito po.
Okay, 5 minutes left. We still have lectures. Please pass to MS Teams. Ian, please resubmit to chat, not meeting chat. This might be deleted after the session has ended. Please resubmit. Ian, Chesalva. This might be erased after the session. Submit it to chat, please.
Ma'am, PM po sa'yo.
Yes, PM. Not here in meeting chat because your answer might be deleted after this session. So please PM me through MS Teams. Okay, pass. Let's proceed.
Wait lang po.
4 minutes left. So my clock here says 3:26. Okay. Okay, 3 minutes left, 3:27.
Ma'am, na PM ko na po.
It's 3:30 now. Please send. Okay.
Sa PM, ma'am, di ba? PM po.
Yes, PM.
Okay. Okay, ma'am. Na-send ko na po.
PM your assignments in MS Teams so it won't get lost. Your assignments are all here in chat. Not in meeting chat, but in chat where you submit your previous assignments. Okay. Okay, so I'm not okay, sharing. Sharing. Okay. What else? Okay. Sa ref. Mm. Tapos, sleep ka na, sleep ka na. Sino? Ilock mo yung gate. Eh, anong malunggay? Ay, huwag mong pakialaman yun. Diyan, doon lang yun.
I-ayusin ko, di ba?
Huwag mo nang pakialaman yun. Yung taas, wag na. Bukas naman. Huwag mong pakialaman yun.
Lagay ko na lang doon na naka-ayos na.
So, let's start. Okay, so I suppose all your assignments are here. Okay, so let's answer number 5. I won't answer number 3. I will answer number 5. Okay, so we have xy plus x prime y prime. So what gate would be best? What do you think? If you have xy plus x prime y prime, so what gate do we have to use for this one? And also this one, y prime z plus yz prime. Hello, class? Hello?
And gate or gate po.
Okay, so we may use AND gates, OR gates, and inverter. Same here, this one. But again, as we have discussed, so whenever we have xy plus x prime y prime, we may use x. This is actually a 1, 1 plus 0, 0. And this one is for y prime z plus yz prime. This is actually 0, 1 plus 1, 0. So what gate is, which gates are those? Okay, so this one, 1, 1 plus 0, 0, and this one, 0, 1 plus 1, 0. What gates do we have to use? Okay, although we may use AND gate, OR gate, and inverter, but this one's easier. So what do you think? What gates? What gates, class?
X and XOR po.
Okay, so we'll use XOR and XNOR. Okay, so we copy. Let's copy some XOR and XOR here. Okay. Okay. And what else? XOR and XNOR. Okay. Okay. Okay, so we have two inputs, no, 3, X, Y, and Z. Okay. Do we need an inverter? Do we still need an inverter? Class?
No po.
Okay, so not anymore. Okay. Again, you can still use the AND or AND, what else? Inverter. But this one's easier, right? Okay, insert lines. So let's have lines. Okay. Okay, so we have 3 lines. Okay. Okay, so let's say this is X. Okay, for X, for Y, and okay, X, oh, sorry, YZ na lang yan. YZ and XY. Okay, so ZYX, so we have XY plus X prime Y prime can actually be represented by a X nor. Okay, so X nor. So again, we will use heavy node to heavy node means connection. Okay. What else? Okay. Okay. Then after that, so we now have xy plus xy prime. Am I right? Am I wrong? Am I right? Class. X nor. X nor is xy plus x prime y prime. Okay. And XOR is or. Okay. C. Okay. So we have y prime z plus yz prime. Okay. So, but then if you use AND gate, OR gate, and inverter, so it's still fine. It's still correct. Okay. But this one's easier, right? Class? So we now have term 1 and term 2 using just 2 gates. Okay, so we're using just 74866 and 74266. Okay, so what else? Are we done? Are we done?
No.
Oh, what else?
And gate.
Again,
Mention.
we still have to use
And gate.
AND gate. Okay, so to connect term 1 and term 2, so we need AND gate. So let's have AND gate here. Let's have AND gate. It's smaller. Okay. It's not done. Oh. Okay. Okay, so AND gate. Okay. So we need an okay, AND gate. Okay. Okay. That's it for number 5. How about number 3? Have you all passed? Have you all submitted? Not yet? How about the others? How about the others? Ajay, Pesado, where's your answer? Why did you delete your answer? Amina. Okay, Amina. Okay, let me see your answer.
Mali.
It's okay. So I won't answer number 3 yet. Not all of you have submitted their answers yet. Please submit. Okay. So how about number 4? Okay. So what theory we can use for number 4? Oh, what can you say about this one? Okay. X prime, Y prime, invert. So what theory? So for this one, we may use De Morgan's theorem. Okay. So De Morgan's theorem. So if you have a, what do you call this? Inversion or prime outside the parentheses, okay, such as this one, x prime, y prime, open, close parenthesis, then you have another parenthesis. So it's like x prime times y prime. So, and then another inverter. So what is x times y? Generally, what is x times y? Class, what is x times y? What is x times y? Class, what is x times y? Class, xy, what gate do we use for
And
xy?
gate, ma'am.
Okay,
And
so we
gate.
will use AND gate. Then, after AND gate, we have inverter. So what gate would AND gate plus inverter? So that is, what gate is that? AND gate plus inverter. AND gate plus
Not gate po.
inverter is actually, again,
Not gate.
NAND gate. So it's actually a NAND gate. Okay, so we may use NAND gate. Okay. Okay. So for number 4, we may use NAND gate. Okay. Number 4. So we may use NAND gate. Okay. X prime times y prime. So it's an AND gate plus inverter. So AND gate plus inverter. So it's actually NAND gate. How about this one? Y prime plus z prime. Y plus z. What gate is that? Y
Or
plus z. OR gate.
Or gate.
Then OR gate then plus
NAND.
plus inversion. OR gate inversion.
NOR gate.
Okay,
NOR
so we
gate.
will use NOR gate. Okay. NOR gate. If you have any questions, clarification, so just feel free to ask anytime. Okay. So we have this one. Okay. Forward this. How many inputs? How many inputs? For number 4, how many inputs? Class?
3.
Class? Okay, so we have 3 inputs. We have X, Y, and Z. So we have X, Y, and Z. So insert X, Y, and Z. Okay. Okay. Okay, still ZYX. So X prime. Okay, so we need X prime. How are we going to have the X prime and Y prime? What gate? Prime. Class.
Not gate po.
Inverter.
Inverter. Okay. Or inverter can also be symbolized by what's that? Okay, so a bubble. Bubble means version also. Okay. What else? So same with Y prime and Z prime. Okay, so we need 2. Okay. Okay, so this is also acceptable. So X prime, Y prime. So we have, okay, so this is, connect this to X. Okay, connect this to X. Then connect to Y. Okay, so what else? This one. Another Y. Okay. Keep on asking why. If you get tired, just sleep with Z. Okay? Okay, so we put a heavy node. Okay. Heavy node means connection. Okay. Question? Okay. What else? Okay, and last. Ay. Okay. Okay. So the output of this is, what's this? X prime, Y prime. So this is X prime, Y prime, prime. Okay. And whereas this one, so we have, Y prime plus Z prime. Okay. To connect these two terms, we will use, what do we use? What do we need?
NOR gate, ma'am.
What is plus?
NOR gate, ma'am.
NOR? Again? Plus?
OR gate.
OR
gate,
gate.
OR
So we'll use OR gate. OR gate. OR. Okay. OR, where are you? Okay. So let's use an OR gate. Okay. Okay. OR gate. OR gate. And what else? Okay. Okay, so the answer would be x prime times x prime plus, okay, plus y prime plus z prime prime. Okay? But okay. So for number 4, we may have an alternative solution for that. Okay, so we may use De Morgan's principle. Okay, using De Morgan's principle. So if we're going to use De Morgan's principle, you still remember De Morgan's principle, class? De Morgan's class? De Morgan's principle? De Morgan's theorem? Class? Hello?
Yes po, ma'am.
Okay, so let's have a recap. Okay, De Morgan's theorem, it states that, so we have x plus y. Okay, then you have a here. Okay, so we have x prime, y prime, then you change the operator. Okay, so let's try. Okay. Okay, using De Morgan's principle. Okay, using De Morgan's principle. So we have, what are we going to do? Okay, so if we're going to insert the prime here inside the parentheses, so it becomes x prime prime, right? You remember? X double prime and y double prime. But you have to change the dot to, what will be the class?
Addition.
Okay, so you have to change the operator from multiplication to addition. So this will become addition. Okay. Okay. Likewise, so y prime, okay, plus, still plus. Okay. Plus y prime, so y double prime and z double prime, but you have to change the plus to what? Class? plus 2?
Dot
Okay,
multiplication.
so we'll change it to dot. Okay. So negation, negative, negative becomes plus. Negative, negative is in physics, in math. Negative, negative is
Positive.
positive. Okay, so negative.
Positive.
Okay, so since we have double negation, so it will become positive. Okay, so it becomes, okay, so it becomes like this. Okay, so as you can see, if you have this one, okay, so it actually equal to just an OR gate and an AND gate. What happened here?
Exist lang po.
Yes.
Ba't pa yung X and Y di dumaan muna sa inverter?
The bubble. Bubble. Bubble means inversion.
Okay po.
Bubble. Okay.
Ma'am, pwede din gamitin yung parang triangle, ma'am.
Oh, yes. Pwede rin yun. Both acceptable. Triangle with a bubble. Also with a bubble. Pag triangle lang kasi, buffer lang yun. Diba? Tama ba?
Yes po, ma'am.
Okay. Okay, so using the Morgan's principle, so alternatively, you may use just an or and and. Okay, or and. Any question? Any question? Okay, so you have number 3 as your seat work for now. Okay, for your assignment, please do assessment number 2.3. For submission, tomorrow. Can we have it tomorrow morning? Okay.
Morning, ma'am.
Is there any
Hapon na lang.
problem? Okay, tomorrow. So I will post this in your assignment tab. Okay. You have to given the logic, given a Boolean equation, so you must draw the logic circuit. Okay, just like we did today. Any question?
Ma'am, okay lang sa papel, ma'am. No?
Yes, yes. Question?
Wala na
Ma'am,
po.
tapos po nung meeting po, doon po magsasend ng file.
Sa chat, PM. PM nga ko. MS Teams.
Okay po.
Then, we'll have unit exam number 2 next week. Okay? Chapter 2. Question?
Wala po, ma'am.
Clear? Clear naman? Clear lahat? Clear
Yes
lahat
po.
na? Kumusta kayo dyan? Taas ng ano natin, COVID case, ha? Nako.
Opo.
Ako
Ma'am,
nga.
patingin ulit ako number
Si
2.
Leo po kasi.
Number?
Leo bike to bike.
Number 2 pong assignment. Number 2. Assignment po.
Ngayon?
Opo.
Ito. Assessment 2.3.
Yung isa po. 2 items po, di ba?
No. It's actually 4.
Okay. Sisend na lang, ma'am, sa ano?
Yes, MS Teams, PM. I'll post this as an assignment. Ilagay ko siya sa assignment tab also. Okay. Okay. So, I'll have it as new file. Okay. And assignment. Save as. Was this assignment 2.3? Okay. Okay. So, let's upload it now.
Ma'am, paano po pag yung ginawa ng circuit yung simplified form? Acceptable pa rin po yun.
Pwede.
Okay po.
Kasi actually the lesser the better, 'di ba? Yung less literal the better. Okay, so I have uploaded assessment number 2.3 for submission when? Okay, tomorrow. Okay? So you can check your assessment tab now. Okay. So what else? You want me to upload this in the class materials?
Yes, ma'am.
Okay. Okay. Any question? So I'm still waiting for some to submit their number 3. What happened? What happened to some of you who have not submitted yet? Okay? Any question? Anyway, any question? Are you having troubles with connections? Uploading to MS Teams? Hello? Any questions? Okay,
Wala na
so
ata.
Wala na po, ma'am.
wala ng tao? Natulog na?
Wala na.
Natulog na? Okay, so I will upload the, wait lang. Upload, okay. Okay, so uploading one item, so please check the, okay. Okay, so that's it. Okay, so thank you who recorded this one. Thank you for the one who recorded this session. I appreciate it. So that's all for now. Bye.
Thank you, ma'am.
Thank you,
Okay.
ma'am.
Bye.
Bye.
Thank you, ma'am.
Yeah, bye. Keep safe.